Good morning. How are you, my all dear students? So, today I have brought another chapter, class 9 mathematics, chapter number 12, Heron's formula, part 1. I hope you will enjoy. So, in this chapter, we will learn very important formula of a triangle which we are going to use to find an area of a triangle. Now, you have already learned about how to find an area of a triangle when the triangle is isosceles or an equilateral triangle. But when a triangle is given with three different measures, how will you find an area of that particular triangle? That we are going to learn from this chapter using unique formula which is known as Heron's formula. So let's learn about this formula, how to derive it and what are all the applications. Now let me give you some brief introduction about this chapter 12 of class 9. In your earlier classes, you have studied to find an area and perimeter of a triangle. You know that perimeter is the sum of all the sides of given triangle. Also, area is equal to the total portion covered in a triangle. Now, let's see or let's recap some of the ideas based on area and perimeter of a triangle. Now, till now, this you are knowing that if you want to find an area of triangle, the formula is 1/2 base into height. Now, here in a given figure, you can see that the triangle which is isosceles triangle with two sides same 5 centimeter and 5 centimeter. The base of the triangle is 8 centimeter and height is 6 centimeter. So, if you want to find an area of this triangle, which formula you are going to apply here is area is equals to 1/2 into base into height. So, 1/2 into base which is 8 centimeter and into height which is 6 centimeter. So, 8 6 are 48 divided by 2, that is 24 centimeter square. You know that the unit that we use for area, that is always centimeter square or meter square. Now, if you want to find the perimeter of this given triangle, what will you do? You will add all the sides given here. Side 1 plus side 2 plus side 3. That is 5 centimeter plus 5 centimeter plus 8 centimeter. That becomes 18 centimeter. So, this is the basics of a given triangle to find an area and the perimeter. Now, so far we know about this. Now, let's learn little more in detail. First of all, let's have a quick revision of types of triangles. So, they are equilateral triangle, isosceles triangle, right angle triangle and scalene triangle. So, first, equilateral triangle. Equi, that means equal. Lateral, that means sides. So, triangle with all the three sides similar is known as equilateral triangle. Isosceles triangle, a triangle with two sides similar is known as isosceles triangle. Right angle triangle, a triangle with one of the angle 90 degree and a given hypotenuse is known as right angle triangle. Scalene triangle, in a triangle if none of the sides are similar, or you can say all the three sides measure different, they are known as scalene triangle. So, area of right angle triangle, So in a right angle triangle, we can directly apply the formula to find the area of triangle as two sides containing the right angle as a base and the height. Here in this figure, you can see one right angle triangle is given with the base of 5 centimeter and height. Height is the shortest distance from the base to the top, which is 8 centimeter. Don't take height 12 centimeter. That is the slanting height. So here we will apply the formula. Area is equals to 1/2 base into height. So 1/2 base, which is 5 centimeter, into height, which is 8 centimeter. Now 8 5s are 40 divided by 2. So your answer is 20 centimeter square for this given triangle. Now, how will you find the area of equilateral triangle? So, to find the area of equilateral triangle, first you need to figure out the base. So, here your base you will take, you have to find your base as well as your height. So, equilateral triangle, here you can see that all three sides are 10 centimeter. But using Pythagoras theorem, you need to find out the height for this given triangle. So, when you apply the Pythagoras theorem, you will figure it out that the height for this triangle is under root 75. Now, under root 75, that means 25 sevens are. Square root of 25 becomes 5 and root 3 becomes as it is. That stays as it is. So, by applying a Pythagoras theorem, you can find the height of this triangle as 5 under root 3. Now, you have the base as well as you have the height. So, base will be 10 centimeter and height that you found, that is 5 under root 3. Now, when you divide 10 with 2, you get 5, and that 5 will you multiply with the 5. So, 5 5s are 25 into root 3 centimeter square. So, this way you can find an area of equilateral triangle. So, first step, you have to find the height of the given triangle, and then you have to apply the formula, that is 1/2 base into height. Now, here comes the Heron's formula. So, before we start with the Heron's formula, let's figure it out, finding area of an isosceles triangle. Let us know how to find out the area of an isosceles triangle whose two equal sides are 5 centimeter and unequal side is 8 centimeter. So, you have to first of all find the height using Pythagoras theorem. So, hypotenuse is given to you and one of the side is given to you. So, using Pythagoras theorem, you will find that the height of this given triangle will be 3 centimeter. Now, unequal side is 8 centimeter. If you just make it half, so that becomes 4. So, that 4 you have used to find the height of given triangle. Now, the second step is area. So, area is equals to 1/2 base into height. So, your base is 8 centimeter and your height that you found is 3 centimeter. So, 8 3s are 24 divided by 2, that comes with 12 centimeter square. Now, area of a triangle by Heron's formula. So, who was Heron? Heron was born about 10 AD, possibly in Alexandria in Egypt. His work on mathematical and physical subjects are so numerous and varied that he is considered to be an encyclopedic writer in this field. His geometrical work deals largely with the problems on the mensurations, and he has derived the famous formula for the area of triangle in terms of its three sides, which is also known as Heron's formula. Now, here comes the Heron's formula. So, area of triangle is equals to under root S into S minus A into S minus B into S minus C, where A, B and C are the three different sides of the triangle and S is equals to semi-perimeter, that is the half of perimeter of given triangle, that is A plus B plus C divided by 2, that is called the half of the perimeter of the triangle or semi-perimeter. Now, what is the importance of Heron's formula? This formula is helpful where it is not possible to find the height of the triangle easily using Pythagoras theorem. It is also helpful in finding area of the quadrilateral. So, Heron's formula that was mainly derived to find an area of a scalar triangle, that means all the three sides measure different. So, let there be a scalar triangle, the length of its sides are known but the height is not known. To find its area, none of the above listed formula is applicable. So, we do not have any clue for the same. So, Heron, an encyclopedic writer in applied mathematics, gave formula for findings r of the triangle in terms of length of its three sides as discussed in the next slide. So, how to calculate the area of triangle using Heron's formula? So, we can calculate the area of triangle if we know the length of all the three sides using formula that has been known for nearly 2000 years. It is called Heron's formula after Hero of Alexandria. The formula can be written as S, which is semi-perimeter, is equals to A plus B plus C divided by 2, and so your formula for finding area is under root of S into S minus A into S minus B into S minus C. Now, Heron's formula, you can see here there is a scalar triangle, that is A plus B plus C. So, area's formula is under root S into S minus A into S minus B into S minus C. Now, what is the need of Heron's formula? Heron's formula can be used to measure the area of triangle whose sides are given. It helps you to find the area of triangle where the height is not given. This includes scalene, isoscalene as well as equilateral triangle. It can be used in our daily life in following ways. When we buy a piece of land, we can find its area by using Heron's formula if that land is in the triangular form. Number 2, imagine someone gave you a triangular figure. It can be 2D or 3D. Now you can find its area by just applying the Heron's formula. Now, applications of Heron formula, for example, if a farmer wish to find the area of his field which is in the shape of quadrilateral, he needs to divide the quadrilateral in the triangular parts and he use the Heron's formula for the area of triangular part. So, here I end the discussion on the Heron's formula and the introduction part. Now, for the next part, I will be discussing how can we find the area when three different measures of that triangles are given, as well as I will also discuss the exercise 12.1. So, see you for the next part.